Okay, today we're going to do a quick lesson on compound interest. So this is just a application of an exponential equation. So it looks very similar to our regular y equals a times b to the x equation. The only thing that's different now is we're using a little bit different letters, but it basically is the identical equation. So our formula that we use for compound interest is a equals p times 1 plus I to the n. So the hard part is just kind of remembering what each of those represent. So the A is the total amount of the bank after you've added your interest. So it's like your ongoing total, or what your amount would be at the very end. Your P is the principal, which means how much money you started with, so how much money you deposited in the bank originally. I is your interest rate. But we got to be careful when we do the interest rate. Make sure it's a decimal, and also make sure it's per interest period. So we'll talk about that a bit more later. And then n would be the total number of interest periods that you're going to use for the calculation. The only thing you got to be careful of when you do the I as well, you got to add 1 to it. So if you have 5%, you'd write that as 1.05. The reason we put the 1 on there is that'll add on our original amount plus the interest. Otherwise, we would just get the interest only. So our first example here just says find how much money you'd have in the bank if you put $5,000 at 4% for 5 years. So if we plug that into our formula, our P is 5,000. Our interest rate is 4%, so as a decimal that would be 0.04, but we add 1 to it, so it's 1.04, and we're going to do that for 5 years. So if you type all of that in your calculator, we get $6,083.26. Okay, so that's your total amount in the bank after 5 years with all the interest that gets compounded per year. So that's a pretty easy question, nothing too complicated. So let's try one more. Okay, so this question, we've got $8,500 we're going to put in the bank for 3 years at 6% per year. But what changes with this question is we say now that the interest is going to be compounded semi-annually. So semi-annually means twice a year, halfway through the year, and then once again. So what we have to be careful of is when we do our interest rate. So our interest rate is 6% per year, but if semi-annually is 2 times per year, that means our 6%, we actually have to divide that by 2. So we only get 3% for the half a year and then the other 3% for the other half. So in our formula, we have to write that as 3%. And then if we're going to do this for 3 years, and we're going to do it twice per year, that means we're going to calculate interest 6 times, right? If we're doing every half a year for 3 years, that means we'd have 6 interest periods. So that's the only thing that's tough with these kind of things. So if it's not done per year, you got to make sure you divide your percentage by how many times it happens per year, and then times your n by that same number of how many times it happens per year. Okay, so in this case we did 6% divided by 2, that gave us 3%, and then we went 3 years times 2, that gave us 6 compounding periods. So that's the numbers we put in our formula. So for this one we get an answer of 101.49.44. So $10,149. Okay, let's try one more. So let's suppose we have $7,000 and we're going to invest it at 8% per annum. That's another word that used sometimes. Annum is just a Latin word for annual, which means per year. And let's suppose it's going to be compounded. Let's do monthly for 2 years. Okay, so in this case, our formula is okay, so for this one, we use our formula. Our 7,000 is our principal. That never changes. So now we just got to be careful. We have 8% divided by 12. So if it's a decimal that doesn't work out very evenly, what you can do is on your calculator, just leave it as 8%. and then just divide by 12 on your calculator, and that way you won't have to round decimals or anything like that. So then our exponent would be for 2 years, but we're doing this monthly, so you'd have 2 times 12, which would be then an exponent of 24. So you can type it in just like that on your calculator, and everything should work, and you should get an answer of 821022. Okay, so when you're doing these tougher questions, just be careful. Make sure you divide your percentage by however many periods there are, and for your exponent, times it by however many periods there are, and then you'll have the correct answer. And that's it.